And what we're going to be doing today is continuing some of the stuff that we did in our first two sessions. In our first one, we created our subscription and we deployed a sample website using the Azure App Service resource. So you can see it here. We created our free plan and deployed our first website. And that should be available and viewable at this azurewebsites.net endpoint. So this was our output of our first session. The second session, we did sort of the same thing. We were actually using virtual machines instead of the Azure App Service to show you a little bit more of a traditional deployment, how you would install Windows servers, how you would set up the Internet Information Services or IIS, and how you would use that to then deploy a website. And I guess in this case, you can see the difference, right, in the terms of the number of resources that we create. Where for the app service website, we really only had 3. We had the app service plan, the app service itself, and optionally some application insights that help send you some telemetry and let you know about how your application performs. And for the website, or the virtual machine deployment, you can see it's a little bit more complex. There's a little bit more going on, where we actually have some resources specific to our virtual machine. In this case, we had the virtual machine, of course, which is the layer of compute, the processor, the amount of RAM that you have or memory running your machine. We had a network interface card that allowed your machine to connect to a local network. We also had your operating system disk, which was like your hard drive or solid state drive that would be containing the data of your website. And in our case, we created 2 of those. And what we did is we used a load balancer and an application gateway, and we showed 2 different ways that you could create a load balanced website, which meant that, you know, if there was a lot of server traffic going to one instance, you could always offload to the second instance and have, you know, an algorithm for how you distribute traffic amongst different web servers. And, you know, to an extent, these are 2 different ways that we can actually build a website in Azure. Today we're going to be going over one more. This one is actually relatively quick. And what we're going to be doing is creating a static website using Azure Storage. So I'm going to go ahead. I'm going to stick in the same demo resource group that we've been using ever since. And I'm going to go ahead and click Add, the same way we had done before. Now in this case, as you might know, in our popular services, one of the ones that's available to us is the storage account. And you'll see that we have blob, files, tables, and queues. We're going to be taking advantage of blob storage in our website here. So I'm going to go ahead and click on that storage account and create a blob storage. And you'll see it's very much like how we were deploying our Azure App Service or virtual machine resources. We have a little wizard here where we can input some of the details. In my case, I will just say Miguel's storage site and call that my storage account name. So that looks good. Performance, standard, premium, I can stick with standard for now. We'll deploy in Southeast Asia as per usual. So my account kind will be storage v2. In order to use the static website feature of Azure Storage, we want to make sure that we're in storage v2. And for replication, we're going to select a basic option, in this case, locally redundant storage. So before, when we were talking about Azure virtual machines, you know how we talked about having 2 machines and making sure that we could distribute traffic to both of them. What that meant was we had a highly available website where if one of the machines actually was impacted or, you know, went down for some reason or there were any issues, we could go back to something like locally redundant storage, and that would or we would have the other virtual machine, my apologies. We'd have the other virtual machine where we would send traffic to. So even if one of those nodes was down, we would still have our website up and running. In this case, we have replication in storage that allows us to set the amount of times our data is replicated within a cloud data center. And this also plays into that concept of availability of our data. Locally redundant storage is your most basic one, where we actually have copies of your data that are spread, you know, throughout a single data center region. So in this case, in Southeast Asia, I can have like 3 copies of my data that are anywhere in Southeast Asia. And that's the locally redundant storage. Zone redundant storage is something we can take advantage of for specific regions. Southeast Asia is actually one of them that have availability zones. In this case, since Southeast Asia has zones 1, 2, and 3, which are sort of separate data centers, physically separated data centers where the power is different and, the wiring is different, making sure that they're isolated somewhat. We can have zone redundant storage where we're actually replicating the data into multiple zones within that data center. So it still stays in Southeast Asia, but it's going to be in different zones in that region. So that's another way we can take advantage of it, provided your region has that support. Otherwise, you have geo-redundant storage, which will actually let you do the replication in other locales. So you could have some of your data copied in Southeast Asia. You could be replicating into the US, into Europe, so that you really have a lot of distribution, and you can make sure that your data is always going to be available, right, and accessible. We also have these RAGRSs, GZRSs, RAGZRSs, so different modifications of the same concept. But for now, I think we'll stick with something basic and go with the locally redundant storage. In terms of the access tier, you'll see that we have hot and cool access. Now this refers to how often you're going to be accessing the data, right? So if it's a file that you're going to be reading a lot, you're going to want it to be in your hot storage. Cool storage is actually priced slightly lower than hot storage. We have a price that's lower than that called archive actually, but these ones will be a little bit more difficult to retrieve. So they're not ideal for types of files or data that you want to be able to access quite often. In this case, we want to stick with hot. Okay, so we move on next. We're going to go to our networking, and we're going to select a connectivity method. In this case, that you could actually, when we were doing our second session and we created a virtual network, which is sort of like your own little local network inside the Azure data center, you actually do have the option to specify a public endpoint where you can be open to any internet access. You also have the option to do a public endpoint, but restricted to a single virtual network. Or you can even do a private endpoint where your storage is not accessible at all, except for by resources within that virtual network. So in our case, I think we want to keep it public since we're going to be doing a public website, right? But it's good to know that there are options for how you can secure access to your data. We'll go to our advanced, and I don't think we need to modify anything here in the advanced. You can read about some of these or try some of these out. In our tags, I think we're fine for now. We can modify these later. And we're going to go ahead and review and create the resource here. So we'll give that a minute. Okay, so that's being created. In the meantime, I'm just going to check our feed and make sure that we're still all up and running. So we can see that the deployment status is underway. Okay, and once we're done, we get the notification as per usual. And now we can go to the resource, check this one out. And this is our storage account information, right? You'll see, similar to the app service and VMs, we have a bunch of different properties that are made available to us so that we can see the performance of our resources at a glance. In our case, we can see some of the things that we had created before, our performance tier, our replication tier, what kind of storage we're using, so that's all good. And you can see actually there's even some data that shows what our usage has been in the past, right? In terms of how much data has left our storage account, how much data has gone in, and what sort of requests we're getting, like how many people are accessing for types of data, or deleting types or updating types. Now, another one that's interesting before we go into deploying the website is talking about the different types of data that we can put in an Azure Storage account. And you can actually see the 4 of them here. I'm going to go from right to left. So we'll start with queues, then tables, file shares, and then finally containers. The first ones are queues. So queues are actually a very simple messaging sort of service where we have a first in, first out queue. So it's just like an orderly line, where you can actually execute or file instructions that are enqueued and dequeued from that data storage. So it's essentially, think of it like a notepad that has a bunch of lines of text, and those pieces of text could have something to do with an application. For example, you could have a contact me form on your website where somebody fills out their contact details, maybe their first name, their last name, and their email address, and hits enter. What could happen is you have a queue there, which is actually taking down the list of data as it's entered, so the first name, last name, and email. And you might have an application that listens for changes in the queue. So it listens and sees whenever somebody enters their first name, last name, and email, I'm going to take the data that's in the queue and I can maybe put it in a mailing list, or I can do some sort of action with it, right? So that's how queues work, right? They're really meant to be sort of ephemeral storage and really a first in, first out process. The next one we have are tables, and this is where we can actually take some more of our application data and make it a bit more persistent. So if you ever had a database or work with Excel spreadsheets or Microsoft Access, you're familiar with how tables work when you're storing tabulated data. Tables here work very much the same, where you can create a table, you can define the different columns that it has, and the row data that it would have, and you can store table data. So what could happen, for example, is your queue data could be taking contact me requests or maybe appointment requests, and the ones that you approve or the ones that you want to be saved could be stored in that table, where you can say, hey, these are the ones that I want to have appointments with. That's going to be persisted data, so it's going to stay there, unlike a queue where it has a certain amount of time before it gets removed. Okay. Now the third one we have here are file shares. And if you've ever worked in an office that has remote file servers or anything like that, you'll be quite familiar with this. A file share is essentially, this is a network file share where we can actually, if you've used your Windows Explorer, right, and you've opened up your files there, your My Documents, downloads, or different locations, the file share will actually create a remote location with its own file structure where you can store files and access them from different machines. What this means is when you create a file share, you're going to get a web location that you can put in your Windows Explorer. And for example, just have in your Windows Explorer a cloud backup place. What that means is you can just take a file, move it to that file share, and it would be backed up onto the Azure cloud. So that's what the file share does in terms of storage. It'll use your files in the SMB protocol to help you manage that. The last one that we're going to be taking a look at, and this is what we're going to be using, is the blob storage. Now, blob storage can really refer to any sort of file type or data type. It can be images, it could be text files, it could be movies, and really you can put any kind of data pretty much into blob storage, and it's kept there, it's replicated, and it's stored at a very low cost. So this is really advantageous for companies or organizations that have a lot of raw data that they want to maintain, they want to have backed up, and they don't want to pay a lot for it, right? So blob storage is a very efficient way for you to maintain a lot of that data and make sure that it's kept secure and backed up. We're going to be using blobs in a slightly different way, where we're going to take some of the website files from our previous application and exposing them over the internet. So in this case, what we're going to do is we're going to use the static website feature here. So if you selected the Storage V2 account, you'll see that in your sidebar, in your settings, you're going to have a static website option, right? Where you can click on this one and you can turn it on. By default, it's disabled, but you can actually have this enabled here, and you'll specify what your index document and your error document is. Now, for most websites, your index static website would go for index.html, which is what we have in our case. And an error document could be like a 404.html, something like that. In our case, we're not too picky, so we're just going to go straight and use the index.html also for our errors. What this means is if somebody goes to a site that doesn't really exist, or we want to throw an error, we'll just redirect them back to the home page. So I think that's okay, and we'll click Save on this one. Very quickly, it's all saved. Now you'll see that once it's saved, there's a message that prompts here that says an Azure Storage container has been created to host your static website. And if I open this up, so I can open this up here, and it'll show in that new tab. But I want to show you another way that we can actually access that. Okay, so let's go back. Let's go to the static website, click on web, and you'll see that our data is here. So I have the option, to upload files. I can, put the website in this place. Now, another thing that we can do, and this is a tool that used to only be available as a desktop app, but is now available in the Azure Portal, is use Storage Explorer to actually view all of the data in our storage account. So I'm going to click here on Storage Explorer, again on the sidebar of my storage account, and it's going to load some data here on the different file shares, queues, and tables, as well as blob containers. Now you'll see for the other three items, there's actually no data because we don't have a file share yet, no queues, no tables provision. But as we start to create that, we'll see those pop up. What we do have is a web container here, and we have the option to add some data to it. So I'm going to go ahead and click Upload. I'm going to select a file, and I'm going to go back to this one here, and I'm going to take my index, my entry HTML, license styles. Okay, I'm going to add all of these files and upload them into my blob storage. It only takes a couple seconds to do because they're relatively small files. Now, the last thing I need to do is create one more quick folder just for my images. All right. So if you're using the desktop app, it's actually a little bit easier because you can just drag and drop the whole thing over. But the nice thing with a web app is we don't have to worry about installing more software onto our PCs. So I'm just going to create an images folder here. Okay, I'm going to upload into this. I'm going to select my files, go into my images folder, add all of these, click Upload, and we'll be good to go. All right, so that looks good, and I can see all of my data is already in the right container. So I'm going to go back to my static website, and let's take a look. So here's our primary endpoint. It's miguelstorage.z23.web.core.windows.net. I'm going to copy this one. Let's open this in a new tab. Let's give it a look. And now we can see, I guess once the images come up, there we go. So we have the same website now that's been deployed as static website storage in Azure. Now this is really effective for certain types of websites, and it's also really effective in creating sort of disconnected or static front pages that have a dynamic back end. What this means is you might have an API or a back-end web server that takes commands and writes commands to a database. It handles application logic and the sort. And what you could do is if you have that API separate from your website, you could be hosting your static website, over in Azure Storage, deploying it here, and it could be calling your API, through JavaScript commands or jQuery or Node.js, whatever it is that you're using. It can be calling your backend API and issuing commands to it. And what this means is you're going to have a very highly scalable front end, as well as a backend that can scale independently. So these are sort of cloud terms. I'll explain them in a little bit right now. Scalability really has to do with the ability of your website to meet increasing demand. One example of this could be a company like Netflix or maybe YouTube or companies like that that have a lot of traffic, and they might see that when they release a new video, they can see a lot of traffic spike for a certain piece of content. Scalability and elasticity is a term that we use in the cloud to really define the ability of your website to meet that demand. So if you only had one server, for example, and that server, was hosting that video and you released a really popular new video, you would see a huge spike in traffic that would cause your server to crash, right? It just wouldn't be able to handle all of that response. In our case, since we're using something like Azure Storage to host our static website, we have something that's pretty highly scalable. We'll show you a way that we can actually scale this even further. Because it's only going to be serving the front end content, so only those HTML files. They're very small. They can be sent over to many people, and meet an increasing demand very, very quickly. At the same time, we could have our back end, which could be actually running on that farm of servers that we did in the second session, and that can be handling those back end requests. And we could be provisioning additional servers. We can be, increasing the capacity of those servers and doing that dynamically. And what that means is the front end and the back end scale independently of one another. It means that I don't have to increase the number of back end servers or those workers that are running in the background just to satisfy all the people that are trying to get my static content. This is a good way that you can decouple parts of your application and make sure that things run smoothly, from the front end to the back end to all the different layers, right? You could even add extra steps like your database end and have that scaling in a different way too, okay? Now, I said that there was a way that we could scale this a little bit further, and I'll show you here. I'll go through the creation. I'll troubleshoot. I have one going right now, but let's add another resource that will help us scale this even further. So let's go back to our demo resource group, and we'll see that we have, one resource for our storage site. I'm going to add one more resource here, and I'm going to add a CDN. So a CDN is a content delivery network. Now this is it's essentially a network of servers all around the world that are storing copies of content and making sure that wherever you are in the world, you have the quickest access to that content. So going back to our example, maybe like with YouTube. YouTube could use something like a CDN where they can take the newest video, like from a popular channel, and they can distribute it. They don't have to have it just in one place like we have with our server site. They can use a content delivery network where they can take a copy of that video and put it in different servers around the United States, different servers around Europe, different servers all around the world, where it becomes easily accessible to anybody in the United States, Europe, or wherever they are. So the content delivery network, it's really just a wide range of servers that keep copies of your data and make sure that you get the closest access and the quickest access to that data. So this is really good for static content. Like that video, which is probably not going to change, right? It's good that they can just create copies there, keep them there, and whoever accesses it, make sure that they're accessing it quickly and they're not overloading our central server, right? So this is one of those ways that we can improve the scalability or the ability to respond to multiple requests in our application. So I'm going to go and create one. So we'll just call it Miguel Storage Site CDN. I'm going to put it in this resource group, and I'm going to select a pricing tier. You can see this has much fewer options. In our case, we have different providers like Microsoft, Verizon, Akamai, and Verizon even has a premium tier. I'm going to stick with Microsoft for now, and I'm going to create a new CDN endpoint while I'm at it. Okay. In this case, we're going to choose a name for our CDN endpoint. This means that rather going to that Z23 website, people can go to this website and it will serve our content. So I'll just call mine Miguel's Storage Site.azureedge.net. We'll just check that that's available. And you'll see in my origin type, I can choose a number of different options. So my origin type could be storage, where let's say if it's a video file that I've uploaded and I want to share to everyone, I could just have a link to it in storage. I have my cloud services, web apps, so even the web app that we created during the first session, we could improve the scalability of that or the availability of it through the web apps. And we could even specify a custom origin if we wanted to. But you'll see that right away, our storage static website is already available. And I'm going to go ahead and click the storage site that I created, Miguel Storage Site. Yep, that's the one. And, okay. Oh, sorry, this is a previous one. I wanted to show you what was happening when I tried this earlier. If you're doing this on a free trial subscription like I am, you might notice that this will come up when you try to create it. In order to create the CDN profile, make sure that Microsoft CDN is listed as a registered resource provider for your Azure subscription. Now, this brings up a good point for how our Azure subscriptions work and how resource providers work. To do this, I'm going to do a quick tangent and go back to our Azure Portal, and I'm going to go to my subscription details. So every Azure subscription is entitled to work with certain resource providers. A resource provider is like, virtual machines, web apps, load balancers, or in this case, CDNs. And you could decide that you want to allow or deny certain resource providers to create resources in your subscription. This is the process of registering or deregistering a resource provider. Now to do this, I can go to my subscription. I will go to my resource providers here in my settings. So I'll click on that one. And you can search for different types that are allowed and disallowed to create resources. This could be useful in certain enterprise scenarios or corporate scenarios where they want to say, hey, we're allowing everybody to use virtual machines, but we don't want to use web apps. We're just not ready for it yet. And what you could do is you could actually go to your web apps here and just deregister the Microsoft web provider, right? So in our case, we saw that by default, the CDN was unregistered. So we want to make sure that we can register it here. So I can search for CDN, and I'll see that in my case, I registered it. So I clicked register, and when it changed to registered, it meant that I could create it. So I can go to my CDN profile. We'll go ahead and click create. We'll wait a few minutes for this one to get up and running. Okay. You could decide that you... All right. Sorry, I was checking my stream. Okay, so we'll let this one run for a little bit. This one takes a little while to run, but afterwards, what we'll have is we can eventually go to our CDN endpoint, access the same website, and we should see the same information there. Now, what you can also do with a CDN is you can actually map this to a custom domain. So for example, miguelstorage.z23.web.core.windows.10 does not sound super attractive, but I might want to use something like miguelarcilia.com, right? And what I can do is I can actually go to my CDN after it's been created and update some of its endpoints to actually say, when you go to miguelarcilia.com, go to the CDN, grab this data, and serve that website. And this is one of those ways, again, where you can round out creating a very professional static website very efficiently in Azure. So those are 3 ways that we've done it. I'll probably take a look at the CDN in a little bit, just in the interest of time. And these are the last 2 resources. So these are 3 approaches that we can take to deploying our websites in Microsoft Azure. First, using the Azure App Service. Next, using the virtual machines. And third, using Azure Storage. Now, these are really optimized for, the last one is really optimized for static websites. The first 2, you might notice, I would say the App Service is really more for server-backed websites. So if you're building a website in Python, in .NET, and C#, you could do it there. And the VM approach is for when you really want a lot of control, or maybe you have specific reasons for needing a backend server. And that's another approach that you can take. Of course, there are many more. We can use things like containers. We can find many different ways to deploy our applications like Kubernetes. But we won't go into those today. What we're going to do just to round out today's session is actually go back to that virtual machine deployment that we had before and show you a different way to actually deploy these resources. In this case, we're going to be using a coding language or an infrastructure as coding language that will allow us to define all of our resources and programmatically deploy all of this in the cloud using a template. In this case, what we're going to be doing is using a tool called Terraform. Okay, so I'm going to go into my Visual Studio Code. So this is a code editor, Visual Studio Code. It's available for free. It's really powerful, really nice to use. I highly recommend you download it. And I'm going to show you a little bit of code here. Now, I don't want you to get intimidated by this. I'm going to go through each of these in order, just so we know what's going to be created. But first, let's start with an explanation of Terraform. So Terraform, again, is it's a tool. Essentially, it's a language. It's a tool that uses a language called HCL, or HashiCorp Configuration Language. HashiCorp is the company that builds Terraform. And it's a declarative language, which means we can declare, or we can, line by line, list out all of our requirements for how our infrastructure gets deployed. Terraform is mainly used for data center provisioning and automation. So in this case, what we're going to be automating is the creation of our second episode content, where we're going to be creating a virtual network, creating our subnets, creating a virtual machine, and having a public IP that through which we can access the machine. Right? We won't do a lot of the stuff that requires a lot of waiting. I will show you more how we actually read the language, how we can use Terraform commands, and then I'll show you an example that I created afterwards. Okay? So let's start with our entry point into Terraform, which is our main.tf file. So every Terraform file uses .tf as its file extension, and main.tf is going to be our first entry point here. The first thing that we do, well, you can see that in green we have comments, so these are really more for documentation. Let me zoom in a little bit here. Can I zoom in here? How do I zoom? I actually haven't tried zooming yet in oh, okay, it's like a browser. There we go. All right, so I've zoomed in here. Let's take a look. So the green part, again, is documentation. You don't need to worry about this. It more describes what we're doing. Let's skip to line 11 and start with our first part here. In this case, Terraform uses a provider concept, which is like your set of libraries if you've done programming, where we can actually take data types or object types that have been predefined and placed in a library, or in this case a provider, and use those to create our program. In this case, our provider is Azure RM, or the Azure Resource Manager, and we're using version 2.10.0. You can also see that I have a subscription ID that points to a data type that's var.subscription_id. This is where I'm going to jump into the second of our files, which is our variables.tf file. So Terraform is pretty cool in that you don't have to have everything hard-coded into your Terraform language, right? You can actually make use of variables that will be replaced, when you're building the code with an actual piece of, actual data. In our case, we define all of our variables in the variables.tf file, and you can see that I can call them in my main.tf file. So in my case, I have var.subscription_id, and in my variables, I've defined that subscription_id here with a default value of null. Now, of course, if you tried to put into a null subscription, it would fail. So we want to have a way that we can override it with a real value. That's where the third file will come in here, which is terraform.tfvars. Terraform.tfvars is where we can actually specify the data that we're going to be putting into this variable. So I'm going to override this variable, which means I'm going to replace null and put some actual subscription data, which is my subscription ID. Okay, I actually have overrides for a couple of the variables here, and we'll see them as we go. Okay, so that was the Azure Resource Manager provider. And at this point, all we've done is we've declared saying we're going to be working with Azure for this Terraform file. Okay, the first thing that we're going to do when we create our first resource in Azure, it's actually similar to what we were doing when we were having our first session, is creating a resource group. Of course, we're going to need a place to place all of our resources, so we want to start with that resource group. Now, the way the Terraform syntax works is we're defining a resource. We're defining the type of resource that it is. So this is an Azure RM_resource_group. So that is a data type that exists within the Azure RM provider. And we're going to give it a name, which is group. Now, group is just the name that it's going to be known as in Terraform. So Terraform uses a state mechanism to make sure that we can maintain the state of all of our resources. When we say that, we could mean things like we have a virtual machine that has one disk, and that's the current state. We could change the state by adding another disk. We could also change the state by removing the HTTP access for the virtual machine. Terraform declares all of this and maintains it in the state of that resource. So if we ever want to change something in Azure, we don't actually have to go to the Azure Portal anymore. We can change how it's written here in Terraform, and it will do that for us. It knows how to do all of that automatically. Okay? But it does this by maintaining that variable name group. So that's the Terraform name of our resource group. In our case, we also specify a name and a location for our resource group. So in our case, we have my location. My default location is Southeast Asia. And my resource group name is RG, but it will be replaced by Terraform site-sea-rg when I actually run it, right? So we're overriding the variables here. So we have the resource group. The next thing we're doing is a virtual network setup. You can see that these comments are actually quite nice. They help sort of break the reading, so it's a little bit easier to read. And you'll see also that Terraform has a very nice syntax. It's very tight, right? If you were to compare this to JSON or the JavaScript object notation, which we use in some of our other templates or our other languages, that one can get very long because when you write JSON, you actually have to, let's not do that. You actually have to open and close your parentheses like this. You might have different ways of doing it, but whenever you're writing JSON code, it can get very unwieldy because so much of that is really just blank spaces. Terraform is quite tight, and I like that they also have a standard where you want to equalize the equal signs so that you can always read the variables and you can see a common starting point for the variable and also the data declaration. Okay. So after creating our resource group, we're going to create a virtual network. So we define a VNet that's going to be the same virtual network name. You'll notice that when we use variables, if I were ever to change this to, let's say, deploy in East Asia or East US, I don't actually have to change all of them every single time. I can just change the location name. So that's a nice reason to use variables. And I have an address space for my virtual network as well. So what I'm going to do is let me just snap this to the side. Okay. So you can see that I have my virtual network name and I have my address space, which is similar to what we did before, right? We created an IP address space, which is 192.168.0.0, and a CIDR notation or CIDR block of 28. This means we're going to get around 16 IP addresses, 11 of which are going to be usable by our virtual network. We also define a couple of different subnets, similar to what we did before. Okay. Anything that we need to discuss in the subnets? No, these are all pretty straightforward. You'll notice that the data that we put here will just be put into this web subnet or this app gateway subnet and the like. Okay, so that is our virtual network done. The next thing we're going to do is we're going to create a web server. Okay, so in our case, we're going to create a network security group. So we're going to start with all of the resources that our web server requires. Before, if you remember, that was let's go back to this one. That's where we had our network security group, which defined what kind of traffic can go in and access our virtual machines. We also wanted to define the network interface card and the OS disk. And then finally, we define the virtual machine. So you're going to see how we declare that here in Terraform. In our case, we start with the NSG. And you can see that I have a site prefix variable here, which is Terraform site, and I believe I overwrote it here, Terraform demo. So we can use the variables not just as a standalone value, but even in sort of a formula like this, where I can take the variable, put it in this quotation marks, and it will be Terraform site-nsg or Terraform demo-nsg. So we can use variables in that way also. Okay. What you need to do is prepend it with a $sign and an opening brace followed by a closing brace, and that's the way that you can use it. Okay. That's if you're doing it in quotation marks. So we have the same location and the same resource group from before. So you'll notice there are ways also that we can specify the resource group. One is we could just say the var resource group name, but in my case, sometimes we're going to need string data. Sometimes we actually need object data. And when we do like the resource group, we might need access to the actual object. In this case, you'll see that the Azure RM resource group.group.name, these first two parts match what we had here. So when we use the Azure RM provider, all of those data types become usable or reusable here, and then we can reference the specific type, which is group, in other scenarios. So if we needed to pass just the name, like just the string value, we can do the variable of the name, or we can reference the resource group directly and take one of its properties, which is the name. Okay, so we have the NSG, and we're going to put it in that resource group. And you'll see I've also defined a couple of security rules right away. In this case, I've defined that I want to access my server by RDP, which is going to be port 3389. And I also want to access my server by HTTP, which is going to be port 80. Okay. All of these are also just other properties that you would notice when you're creating the security rule in the Azure Portal. The next thing that we do is create a public IP, which is going to be named server IP. And we're going to be creating it in the same location, same resource group. I can also specify things like the SKUs, where I'm going to have a static IP address with a basic SKU. And we can move from there. So we have the public IP. And then the next thing we're going to create is the network interface card. So that's the one that your virtual machine uses to be part of the local network. In this case, it's called server NIC, and it's going to have an IP configuration where it will be, and you'll see now where we actually reference some of our data types directly. Let's do this. Okay. So what we're doing is we have an IP configuration named ipconfig1. I have a subnet ID where I'm actually going to make this part of my web subnet. So you remember before when we created different subnets, we can define what virtual machines belong to a subnet by associating the network interface card, right? So this is the way that we assign it through programmatically or declaratively. My private IP address will be dynamically allocated, and my public IP address will be the server IP that I just created. So it will make sure that it's bound to that, okay? And I even have a type here. So in terms of how granular you can declare how your data center, your infrastructure is defined, I can even do this where I can associate a network security group to a network interface. So as before, where we had a network security group, there we go, and we could have associated subnets or associated network interfaces that are bound to the network security group, we can actually create that association in the code. So in my case, I just provide the ID of the network interface that I'm going to be binding and the network security group that I'm going to be binding it to. Okay? And lastly, this is where we get to the virtual machine, our server. In my case, we provision a server with a name that's going to be Terraform Demo VM. I'm going to deploy this in Southeast Asia in the same resource group. I can choose my size. Last time we did a DS1v2, which is a single core and 3.5 gigabytes of RAM. And then I can specify what my username and password are going to be to connect. In my case, I have my Azure username here. My password is null. I've overridden this. I'm not going to show you the password. There are other practices that you can apply to make sure that you've secured your credential. We won't do that today. But I can specify my username and password. And I will make sure that my server has a network interface associated, which is the one we declared before. And we're going to be creating a Windows server using the OS of 2016 data center and taking the latest version of that. The last thing we're going to do is define our OS disk, which is that hard drive or solid state drive. We're going to say that it has LRS storage, LRS, GRS, ZRS, like we discussed before. And our caching is going to be read-write. Okay, so that is all okay. I won't go into creating an application gateway because this takes a little bit too long, right? I'm not gonna go in and do this part. So this is our Terraform file, and what we're going to do is actually run through the commands that you would issue to access Terraform. The first thing that we're gonna do is I'm gonna log out just so I can show you the process here. Okay, so I'm in the same directory. So this is my PowerShell. My PowerShell terminal. Let me just change my sizing a little bit. Okay. So this is my PowerShell terminal where I'm going to be issuing commands to Terraform. And I am going to start by, did I make any changes here? Oh yeah, okay, I don't need to do that. Okay. The first thing I want to do, I'm just going to clear my TS state. So I actually have some resources that I created before. I'm going to clear this, so we're just starting from a clean slate. Ideally you don't want to do this. I mean, like, never do this if you're doing it in production. In my case, I just have an old demo that I'm making sure I don't override. Okay? So we're going to go and issue our 3 Terraform commands. There are 4 that you can use. And the mnemonic that I like to have for it is iPad. In this case, it's Terraform init, which is your I. We have plan, your P, apply, and destroy. Now, you're not always going to use destroy, but init, plan, and apply are going to be pretty common for you. So if you ever forget what those 4 essential commands are, you can remember iPad, and I think you'll be able to retain it. Okay, so the first thing I want to do is actually go in and Terraform init. Okay. So what Terraform init does is it makes sure that my Terraform files, it recognizes all of my Terraform files, it understands that this folder is where I'm going to be working and applying all of my code. So it does all of this plumbing for you. So you just want to make sure that you do that. You technically only have to do this once unless you change providers. So if you do provider, add a new provider, then you'll need to run init again so it can download that library. Okay, so we're okay with that. I'm going to do a Terraform plan. Okay. Now you'll see that there's an issue when I hit Terraform plan. The reason this is there is because I am not authenticated to use the Azure command line interface. So Azure command line interface, or Azure CLI, is what I need, or what Terraform uses to issue commands that will do remote provisioning of my resources in Azure. So rather than using the Azure Portal, it's going to use remote commands on the command line interface. So what I need to do to resolve that is go to AZ. AZ is the Azure command line interface, and I'm going to do AZ login. Okay. So AZ login is just going to open a browser window for me here. I'm going to sign in, and once I'm signed in, all good. So it just lets me know that I've logged in. It's going to do a quick check and see which subscriptions are accessible. Okay. Let's give this a minute. Okay, there we go. All right, so it knows that I have my Azure subscription 1 with this tenant ID and my my owner user. So I'm good. Now I can go back and do my Terraform plan again. Okay. Oops. Hold on. I'm logged in, right? Okay. Let's just make sure that, did I, oh snap, I deleted my TFRs file. Let me go back and recover that. Sorry about that, give me a minute. Terraform.tfrs, let's restore this. Okay, sorry, I deleted that, that's why. So what happened here was, it was what I was saying before, it's actually, okay, so it was actually using null as my subscription ID, which is definitely, it's not a subscription that I actually own. So that's because I deleted the TFRs file. So now that I have it back, it should be able to read this one. Let's do a Terraform plan again. Okay. And you can see it actually there. It creates the terraform.tf state as before. So it's maintaining a state dictionary, just saying that, oh, this resource group, it exists, you know, et cetera, et cetera. So let's review what actually came up. Now, after doing the Terraform plan, it gave us, you know, a plan. It didn't actually do anything yet, but it's telling us this is what will happen when you apply Terraform. In this case, it's going to issue create commands. If there was destroy, it would have a red dash and say destroy. And it's going to be creating a bunch of new resources. So I can see that it's going to create a server network interface card called server NIC, and it's going to have some names. You'll see that some of them are called known after apply, which means it will tell you this information after it's been created, right? So it's going to create all of these different resources, everything that I've defined. Okay, that looks good. And my summary, it says it's going to add 9 resources. It's not going to change any of them, not going to destroy any of them. Okay. It says, okay, so it has a warning here to use address prefixes instead of address prefix. I'm okay with that. It's not going to break the code, but I can change that in the future. All right, and now what we're going to do is we're going to do Terraform apply. So plan was our process of just saying what is going to be done against it, but will not actually do anything. It's only when you do apply where we will actually issue this command. This is important because you might want to use Terraform plan just to make sure what will be impacted if I change certain, you know, data in my data center, right? But the nice thing is when you do it in Terraform, since it's all defined in code, Terraform will tell you exactly what's going to be modified. If you're doing it in the portal and you're sharing those resources with a lot of other people, you might not know what would happen if you delete something, right? So this is one of those ways that you can actually, use code and use a declarative template to be very efficient with how you manage that cloud infrastructure. So you'll see here, it's going to give me a quick timeline of what's happening. It starts with a resource group, so let's scroll up here. It says creating and creation completed after a certain amount of time. So it'll say that, okay, I have an issue here. Operation not allowed. Okay, I think I'm at my total amount of cores. Okay, so I'm in a free trial subscription. That's okay. It means I can't actually create more cores, but I'll show you what was created before that, and then I'll show you the demo that I had prepared. Okay, so in this case it said creating, and it's going to create the resource group, and it gives me even the ID and how long it took. So it only took a second to create, so it's pretty quick to do, right? And it did that for all of the other ones. It just stopped at the Windows virtual machine. So let's see what was actually created in Terraform. Okay, I'll go to my resource groups here, and let's see what was the name that we had specified before. It's Terraform site-sea-rg. So let's find that here. So that was created. And we'll see that it's actually created some of these resources already. So it created the virtual network. You can see that the network interface is associated. My address space is defined as I declared it in the code. And I have the two subnets with the address spaces already pre-done. So, before when I was doing this and it took a long time for me to create all these manually and I had to remember all of the steps to do it, I can now define it once in my code and just have that run automatically. I can just change the variable names and make sure that my subscription can handle enough cores, right? But I can change the variable names and just have it create a new instance of that web application with a different endpoint or a different IP address, right? So let's also see what else was created. So it created the VNet, it created the NSG. So let's take a look at the NSG. And you'll see that the inbound security rules that we defined, port 80 for HTTP and port 3389 for RDP, are already there, right? They've already been defined for us. So if we have a certain baseline where we say nothing can use RDP, nothing can use HTTP, Terraform can actually, identify this and make changes. So if, for example, and let's go back here, let's go to my main.tf and say I don't want to have RDP access anymore. We'll comment that out. Let's save, and let's do a Terraform plan again. Let's see what's going to happen. So I'll do a plan, and you're going to see it's going to be slightly different this time. Okay. All right. It's refreshing the state. So refreshing state is an interesting one because, again, this is just making sure it's going to compare what you've declared before and what the current state is now and see, are they the same? And if they're not, then we actually need to change something. That's why you'll see that there's one to add, which is the VM. We know that's not going to work right now. We know that there's one to change, though. So let's take a look at that one. In this case, you'll see that our network security group will be updated, and we will remove the 3389 and 80. So it's going to remove both of them, and it's just going to re-add 80. Terraform has different ways of modifying resources. Sometimes it knows that it can just update it directly. Sometimes it knows that it has to destroy something and then recreate it. You might not always have to know, but Terraform knows, which is good. So it can take some of that work off your shoulders. But you can see just by removing this, if I click Terraform apply, so this is going to fail at the VM step, but that's okay. We should see the change still propagate. So let's Terraform apply again. Okay. When it's done refreshing the state, it'll ask me to confirm by saying yes. Okay, just give that a minute. Okay, so here we go. Let's hit yes. And we'll wait for that one to run. In the meantime, I'll show you what a completed Terraform deployment looks like. I had one here, which was the Terraform demo site -sea-rg. And let's go back to this one. And you'll see that, so the VNet was created, the network interface, NSG, OS disk, public IP address, and the virtual machine. All of the requirements that we had for our basic website, maybe except for the load balancer, right? The load balancer and the application gateway, they take a little bit of time to create, so I didn't want to do that one live. But in this case, if I go to my Terraform site VM, you'll see that I have a private IP address, I have a public IP address, and I can actually issue a remote connection, view this one, and you'll see like before, I just finished up installing IIS on that public IP address. So we'll just check here that it is running on that public IP. In the meantime, we can also even check it here and see if that's okay. Okay, there we go. So we know that the web server is actually running. Terraform actually is powerful. It's actually really powerful in that we can even, in this case, it's IIS, but remember before we took some of our static code files and uploaded them into the IIS start location in our server. Terraform can actually even have post-install commands where you can take some instructions like a script and automate the process of installing IIS, inetpub, going to www root, and then replacing it with those server files. So it's really powerful in that sense. But in our case, we know that we have a working IIS server, and we can start deploying our resource onto this. So imagine how quickly you could get started if you had a Terraform script. You just hit Terraform apply. I'm going to run that command and then start provisioning it or giving a server to your developers or your IT team so they can start working on it, right? That's very different from how it used to be in the past, where provisioning machines and making sure that they met our standards used to take a very long time. Now we can just write out our standards and know that Terraform and Azure are taking care of that for us. Okay, so I believe this one is done. Let's see. Okay, so the virtual machine part failed again, but that's okay. Let's go back to this demo, the site here. Let's go to the NSG and let's have another look again at the rules. And you'll see now RDP was removed. So without destroying everything, all it did was it knew that it had to change a certain rule, which in this case is HTTP, and remove the RDP inbound port rule, and it updated that for us. Okay, so that was Terraform in a nutshell. I think before I close out, I'm going to do a close out with a quick summary. But one thing I want to show you is how much I spent for everything that we had running. So this is a month of resources running, the app service, the virtual machine, the serverless websites, and how you actually manage and view your costs in Azure is done through your subscriptions tab. So if I navigate down here in the Azure Portal, you might see it up here in your previous services if you'd accessed it before. If not, you can just navigate to it in your subscriptions, and you'll see your subscription name, your role, as well as the spend. So let's wait for this to load up. But it shows us that in the 30 days or so that I've been using this from my $200 credit, so I didn't get to maximize it, right? But I think I had some pretty good projects going from it. I spent around $40. And these were, a number of virtual machines that I spun up. I had my virtual network, my gateways, my load balancers and all. And I can actually see what my usage was for the period. So for the past 30 days, I can see what my trend was on spending. I can see that, I spent a good amount of my money was going towards the app gateway, right? I had my load balancer also running, and my others is around $13. So if I actually go into this, I open up a part of my Azure subscription called Cost Analysis, which will show me the accumulated and per resource costs for a certain time period and let me know how much I was spending on different resources. So in this case, it gives me much of the same as before, but I can go to my cost by resource and I can actually see, in a descending order or however I want to view it, which resources were costing me the most money and, how much was I spending for certain things. This is very good to do when you're running a cloud project because it can be hard to predict what your actual cost is going to be. Having something like cost analysis, or this will let you know exactly what you're spending on. You can say, hey, I don't feel like we need to spend that much on load balancers since we're already using an application gateway. If we were to remove that, could we save some money? And in my case, yes, I could save maybe 40% of my bill just by removing my load balancers. So if I know that they're not necessary, I can use cost analysis to see exactly how much it's impacting me, and I can, take action as needed. All right. And I think that's about it for cost management. Oh, if you're really careful, or if you really want to make sure that you don't go over any budgets and you're still doing this, as an exploratory phase, you can take advantage of budgets, which you can actually create in Azure, that would say, if I were to spend more than a certain amount, let's say I only have $20, I don't want to spend more than $20, I can create a budget that says every month I want to spend not more than $20, and if I do, then you have to start just pausing my services. So Azure can actually do that, where it can give you an alert and say, hey, you're starting to get pretty close to the amount that you budgeted, so please make sure you're ready. And if you exceed it, we can take action and say, hey, we'll just pause everything there. So it's one of those ways that you can set a finite budget for yourself in terms of your learning and your exploration of the cloud, and not feel like things are going to get out of hand. Okay? So that's about it, and I think that's where we will leave off for this session. Just a quick summary of what we've done in the past 3 sessions. Again, the first time we created our website using Azure App Service. Very simple, very quick. Second time, a little bit more complex, where we did more of a server-based deployment, creating virtual machines, load balancers, and application gateways using our infrastructure as a service. And the third time, we went back to our platform as a service and went to our storage site, or used a storage account to create a static website and distributed it through the CDN. Lastly, we also covered how we would use something like Terraform as a tool that can make all of this a lot easier for us, because it automates the creation of these resources. And I think that was pretty much it. So if you do have any questions, you can always shoot me a mail. These videos are going to maintain on YouTube and be streamable there, be viewable there. I hope you were able to find something useful from these sessions, and I hope you're able to apply them. And I will make sure that the link for this YouTube video is pasted after the fact. Otherwise, thank you very much. So this is Miguel Arcilia. Thanks for attending these hands-on Azure sessions, and we'll come back probably without a free trial for future sessions. All right, take care, everybody.